All right, let's say you want to build a payment system from scratch for your website. User journey is simple. Users enter a card, you charge them, and then they get a receipt. So let's actually try building it, and I'll show you where it breaks at every step. Version 1, the naive approach. The user enters their card details in the browser. Stripe's JavaScript library securely collects those details and sends them directly to Stripe, so your server never sees the raw card number. Stripe processes the payment and sends a response back to your server. Your server marks the order as paid in the database and sends a receipt to the user. This design is good for a hackathon, but it needs a lot of improvements. Here's where it breaks. If the user's request times out due to a Wi-Fi hiccup or slow server, then they submit the request again. Stripe will charge them a second time, and now you've got a duplicate transaction and an unsatisfied customer. It's a huge mess. Version 2, idempotency keys. The client generates a unique key for each payment attempt. This key is usually a UUID. The user sends this UUID with the request. Your server stores that key in a database row before doing anything else. If the same key shows up again, you return the stored result instead of charging the user again. Things get more interesting here. For each transaction, storing one row called payment with its status is not enough. A real payment has a life cycle. It gets authorized, then captured, maybe refunded, and maybe disputed 3 months later. If you keep updating one row's status again and again, you've thrown away your audit trail. And the moment a regulator or a finance person asks, what happened on this payment, you've got nothing. Version 3, an immutable ledger. Don't just overwrite payment status in one row. Every state change is a new row. For example, payment initiated is one row, and payment captured is another row. The current status of payment should come from the full payment history, not just the latest update. So if payment events from Stripe arrive in the wrong order, your system doesn't panic or mark the payment incorrectly. It looks at the full timeline of payment and decides the correct state. We still have one issue. Payments aren't synchronous. You send the payment to Stripe, you get a pending status back. The actual authorization might come 10 seconds later, and the capture may happen the next day. The thing is, your server isn't sitting there waiting for any of those status updates. Version 4, webhooks. Stripe uses webhooks to reach back to your server. Whenever a payment status changes, Stripe sends a message to your server. Your server checks the signature to confirm the message is really from Stripe, checks the event ID so you don't process the same event twice, and adds a new row to your ledger. So here's your final architecture. The client sends an idempotency key with every payment. The server writes an intent to the ledger before calling the processor. Webhooks flow in over the next minutes, hours, and weeks, each one appending another event to the same ledger. The current status of any payment is derived from the full event timeline for that payment ID.